Bleed air and electrical power are required for engine starts. Bleed air turns the starter motor. The sources of bleed air for engine starts are the APU, a ground air cart, or the other engine. Today we will use the APU to supply the starter air. Electrical power opens and closes the engine start valve. Each engine has two igniters. The AC transfer bus supplies power to the left igniter, and the AC standby bus supplies power to the right igniter. The engine start lever has two positions. The cutoff position de-energizes the ignition system and closes the engine fuel shutoff valve and the spar fuel shutoff valve. The idle position energizes the ignition system through the EEC. Electrically opens the spar fuel shutoff valve, and electrically opens the engine fuel shutoff valve through the EEC. Controls for the engine start and ignition system are on the engine start panel. The ignition select switch has three positions. Ignition left and ignition right select the related igniters for the two engines. The both position selects the left and right igniters for each engine. Each engine start switch has four positions. When the engine start switch is moved to the ground position, the start valve opens, and the engine bleed air valve is given a signal to stay closed. The start valve open alert illuminates on the engine display to show the start valve is open. For ground starts, the EEC arms the selected igniter. For in-flight starts, the EEC arms the left and right igniters. In the continuous position, the EEC arms the selected igniter. In the flight position, the EEC arms the left and right igniters. The continuous and flight positions have no effect on the position of the start valve or the engine bleed valve. This is a review of the engine start and ignition system. Touch each control to show information. When finished, touch the green arrow. Let's now start the engines. The captain announces the engine start sequence. Normal start sequence is engine number 2, then 1. It is recommended to change the selected igniter for each flight. For today, select the right igniter. Move the number 2 engine start switch to ground. The start valve opens, and the start valve open alert shows on the engine display. As the starter motor turns N2, the N2 indication starts to increase. Before you move the start lever to idle, make sure there is movement in the N1 indicator. And N2 is at 25%, or at maximum motoring and a minimum of 20% N2. Maximum motoring is when N2 acceleration is less than 1% in approximately 5 seconds. Now move the right start lever to idle. The fuel flow indication starts to increase. Within 10 seconds after the start lever is moved to idle, the EGT indication shows an increase in temperature. At 56% N2, the engine start switch moves to auto. The start valve closes, the engine bleed air valve opens, and the start valve open alert extinguishes. The first officer makes sure the alert is extinguished and the engine start switch is in auto. The first officer tells the captain when the starter has cut out. If the start switch does not move to auto automatically, the captain moves the switch to auto. An increase in oil pressure must occur before the indications are stabilized at idle. The first officer tells the captain when oil pressure increases. You must monitor N1, EGT, N2, and fuel flow indications until they stabilize at idle. When the engine indications are stabilized at idle, the other engine can be started. Let's start engine number 1. Move the number 1 engine start switch to ground and monitor engine number 1 indications. When N2 is at 25%, monitor the start until engine number 1 indications are stabilized. Remember, the first officer informs the captain when the starter has cut out and oil pressure has increased. The flight is now completed and the airplane is at the gate. Let's shut down the engines. Before engine shutdown, make sure the electrical buses are powered by the APU or by external ground power. For today, use the APU. Now move the engine start levers to cutoff. This completes the engine shutdown. The EEC supplies engine ground start and flameout protection. For engine starts on the ground, the EEC monitors engine parameters. In flight, the EEC prevents engine flameouts. Let's first discuss protection for ground starts. The EEC monitors engine parameters for hot starts, EGT start limit exceedances, and wet starts. An EGT start limit line shows when N2 is below 50%. A hot start is when the EGT quickly increases or when the EGT approaches the EGT start limit line. If the EEC gets inputs of a hot start, the white box around the EGT digital readout flashes. The box goes to normal when the engine reaches idle N2, or when the start lever is moved to cutoff. Move the start lever to cutoff. If the EGT is more than the start limit line, the EGT dial, readout, and box color change to red. The EEC shuts off the fuel and de-energizes the igniters. The indication goes to white when the EGT goes below the start limit. After engine shutdown, the EGT box becomes red to show an exceedance has occurred. A wet start occurs when the EGT does not increase after the start lever is moved to idle. Fuel can collect in the engine and on the ground around the airplane. If a wet start occurs and the engine start is not aborted, the EEC shuts off the fuel and ignition 15 seconds after the start lever moved to idle. This is a review of the engine ground start protection. The EEC monitors engine parameters that show a flameout can occur while the engine start switches are in auto. The EEC energizes the left and right igniters if there is a sudden N2 decrease or N2 is below 57%. The EEC de-energizes the igniters after 30 seconds. Or when N2 decreases below 50%. There are three other types of engine starts: ground air, cross-bleed, and in-flight. The first type of engine start uses a ground air source to start the engine. The ground air source is connected on the right side of the airplane. AC power from the APU or ground power must be available. In this example, a ground power cart is used. For safety reasons, engine number 1 must be started first because ground personnel and equipment are in the area of engine number 2. The APU bleed air switch must be off. This closes the APU bleed air valve and isolates the APU from the high start air pressure. Make sure the duct pressure from the ground air source is a minimum 30 psi. Use normal start procedures to start engine number 1. After engine number 1 is stabilized at idle, disconnect the external power equipment. Cross-bleed air is used to start engine number 2. Let's now look at a cross-bleed engine start. A cross-bleed start uses bleed air from the other engine. For today, we'll use engine number 1 to start engine number 2. Make sure the engine bleed air switches are on, the APU bleed air switch is off, and the isolation valve switch is in auto. This makes sure bleed air from engine number 1 is available to start engine number 2, and the APU is isolated from the high start pressure. To start engine number 2, engine number 1's thrust must be increased until there is a minimum duct pressure of 30 psi. Before engine number 1's thrust is increased, for safety reasons, make sure there is no equipment or personnel behind the airplane. Now increase the thrust on engine number 1 until the duct pressure shows 30 psi. Engine number 2 is ready to start. Normal start procedures are used to start engine number 2. After starter cutout, decrease the thrust on engine number 1. Now, let's look at in-flight engine starts. There are two procedures used for an in-flight engine start: cross-bleed and windmill. The airplane's altitude and airspeed must be checked to find the correct procedure to use. The ground start protections are not available for in-flight starts. The cross-bleed start indication is shown if an in-flight cross-bleed engine start is necessary. The engine start switch is put in the ground position. For a windmill engine start, there is no cross-bleed start indication and the engine start switch is put in the flight position. Now let's look at some non-normal conditions related to engine starts. There are 5 conditions when you must abort an engine start. The first condition, no N1 rotation, occurs before the start lever is moved to idle. When this condition occurs, the engine start switch is moved to auto. Three abort conditions occur after the start lever is moved to idle. If there is no increase in EGT 10 seconds after the start lever is moved to idle, or if there is little or no increase in N1 or N2 after the EGT starts to increase, or the EGT quickly approaches or goes above the start limit line, the start must be aborted. The start lever is moved to cutoff. Motor the engine for 60 seconds in the ground position to discard the fuel and cool the engine. The engine start switch is then moved to auto. The last abort condition is no oil pressure by stabilized engine idle indications. The start lever is moved to cutoff. When N2 is below 20%, move the engine start switch to ground. This prevents damage to the starter. After ground is selected, motor the engine for 60 seconds. And then move the engine start switch to auto. This is a review of the abort conditions for an engine start. The last non-normal condition related to an engine start is when the start valve open alert remains illuminated after starter cutout. To prevent damage to the starter, all bleed air sources to the starter must be isolated. If the APU or engine bleed air is used for start, the isolation valve and related bleed air valves must be closed. In this example, the APU is used to start engine number 1. Now set the bleed air panel to isolate the related bleed air sources. With the isolation valve switch in close and the engine number 1 bleed air switch and the APU bleed air switch in off, all related bleed air sources are isolated. For all ground starts, move the start lever to cutoff. If ground air is used for engine start, the ground air source must be disconnected.